everyone, this mini lecture's on balancing chemical equations. Just before I get into it, I just want to remind you of a couple of things. So first of all, why do we balance chemical equations? Well, again, essentially it's all to do with complying with that law of conservation of mass. You should be very familiar with it. It's saying that atoms are neither created nor destroyed. So what that means is the type and number of atom on one side of the equation must equal the type and number on the other side of the equation. The other rule that's important with this when you're balancing equations is that you can't change the subscripts in the chemical formulae, because that will actually change the formula of the thing that you're talking about. All you can do is change the coefficients. They're the big numbers that sit in front of the chemical formulae. The other thing that I'll be pointing out to you in this lecture is that there's a number of different strategies for balancing these particular equations. Okay, let's get into it. So in a previous mini lecture I was giving this example here where hydrogen gas, there it is there, reacts with oxygen and it forms water. And I gave you the example where I just showed you that H2 plus O2 gives H2O, and the problem being that if it is simply just H2 plus O2 gives H2O, it's unbalanced. That is, you'd start with 2 atoms of hydrogen, 2 atoms of oxygen. You'd end up with 2 atoms of hydrogen but only 1 of oxygen. And so therefore, to comply with this law of conservation of mass, we have to balance it by putting some coefficients in. And these are the 2 coefficients that we use. So if we put a 2 here and a 2 here, the equation's now nicely balanced. How does that work? Well, we've got 2 molecules of hydrogen, H2. So in total, we've got 4 atoms of hydrogen here. We've got 1 molecule of O2. In other words, we've got 2 atoms of oxygen here. We've got 2 molecules of H2O, which means we've got 2 twos of 4 hydrogens here, which is what we're after, and we've got 2 ones of 2 oxygens here. So you can see here we've got 4 hydrogens, 2 oxygens, 2 oxygens. So that particular equation is now balanced and it's complying with that law of conservation of mass. I can't stress enough that the only way you can do it is to play with these coefficients. If, for example, I tried to get a couple of oxygens on this side by subscripting a 2 here, then the nature of the molecule here changes completely. The formula for water is H2O, that's the end of it. If I were to write here H2O2, right, that is not the formula for water. And you might think, well, why would I write H2O2? Well, it's a common mistake students make, that they're tempted to just put a 2 here, because then if you just ignore the coefficients there for the moment, the thing is balanced. I'd have, scratch that out for a moment, I'd have 2 hydrogens here, 2 oxygens here, I'd have 2 hydrogens here and 2 oxygens here, so it'd be balanced. But the problem is this thing, H2O2, is not water. It's actually hydrogen peroxide, which is a bleaching agent, and it's what you use when you bleach, for example, hair. It's also used as a bleaching agent in things like toothpaste, and if you look in the ingredients list in some types of toothpaste or teeth whitening agents, you'll see indeed that it does contain hydrogen peroxide. Obviously, hydrogen peroxide is not water, it's very, very different. So again, I can't stress enough, only change the coefficients, don't change the subscripts for any of the atoms in equations. Alright, that's just a little summary of what I've just been talking about there. Now, the other thing that you'll have to come to grips with is the techniques involved in balancing equations, and it's a little bit of a case of you just fiddling around with them. You've got to normally play with them a little bit, And the best way to learn how to do it is not to listen to me, but to actually get in there and practice the examples that are in your book of readings. So I can't stress that enough. There's a couple of little hints. I mean, that's obviously not a hint, that's a rule, you must do that. The next thing you've got to do when you're balancing things is you've got to work out which elements aren't balanced. And then, of course, you start putting coefficients in front of them. The problem often when you're putting coefficients in front of a molecule is because it consists of two different types of atoms or even more. Once you've changed one molecule, once you put a coefficient there, not only have you changed the number of atoms for the element you're considering, but you've also changed the other one as well. So to give you an example of that, if I just get my pen here for a minute, if I write H2O like that, and I put a 2 here, it's pretty obvious. Let's say I wanted 4 hydrogens. It's pretty obvious that I've also now got 2 oxygens, and that might actually unbalance your oxygens. So then you've got to go to the other side of the equation and fiddle with that as well. Okay, there's just a little summary there for you again. You can look at that at your leisure. As I said, you can read this stuff as much as you like. The important thing is that you actually get in and do the exercises. There's some other little hints there. I'm not going to go through these in this lecture. You can have a look at those. One thing that you can do, though, that I will just point out to you, is you can sometimes, it's not really cheating, but you can kind of fix things up quickly by, instead of using a whole number, you can actually use a fractional number. So for example, if you look at this thing here, we've got oxygen here, O2, and we put a 3.5 in front of it. So to work out the number of oxygen atoms, you just multiply the coefficient by the subscript. So clearly there, that's going to be 7, okay, because 3.5 times 2 is 7. So you're after an odd number of oxygens in order for the thing to balance up. If you don't believe me, if you look over here, we've got 2 2s are 4 oxygens there, plus 3 1s are 3 there, 4 and 3 makes 7. So that equation there is actually balanced. The problem with writing the equation like this is that it looks a little inelegant using a fraction here, because if we were to think of this as being molecules of oxygen, there's no such thing as half a molecule. So, but what you can do is you can actually multiply everything through by 2, and then you'll end up with a balanced equation. And there it is there. You can see I've multiplied everything through by 2, so I've now got a 2 in front of this because 2 1s are 2. 2 times 3.5 is 7, there it is. 2 2s are 4, 3 2s are 6. So that's another little strategy you can use as well, is to use fractions. I've already talked a little bit about polyatomic ions, and I said to you that I would like you to remember the names and formulae of just a few when they were in a previous table. Here they are here again. Rather than trying to add up all the oxygens and carbons and hydrogens and so forth in polyatomic ions, it's best to actually think about them as being units. So rather than thinking of, for example, this as being 3 oxygens, you think of the whole thing as being a nitrate. So here's an example here where we've got a reaction. This is going to be iron oxide. This thing here is sulfuric acid. It's reacting together and forming iron sulfate and water. At the moment, that particular equation isn't balanced. You can see at a glance, for example, if we just look at, and this is where we'll look at the polyatomic ions as a group. I've got 1 sulfate here, but I've actually got 3 sulfates here. So that's not balanced at all. But you can think, well, all right, if I've got 3 sulfates here and 1 here, I could actually put a 3 here like that. Now, it still mightn't be balanced, but you're on the way. In fact, if we just look at the rest of this example here, you'll find that what we're after is a 3 here to get all the hydrogens right. That's actually balanced now. The X there is just supposed to represent the sulfate. You can see here that the whole thing's now balanced. You can go back and look at that at your leisure. Okay, finally, what I've done is I've set up a number of mini tutorials where I've actually recorded me on paper balancing some equations. If you look at those on YouTube, that'll help you as well. But at the end of the day, the most important thing for you to do is to get as many problems as you can involving balancing equations and get in there and just play around with them. It's the only way you're going to learn how to actually do them. Alright, that's it for this mini lecture. Bye.